Alright, hey everyone. So last time I made a video, I was basically just talking about what I want to accomplish with this channel and like the formats of the video that I'm going to make are. So starting off, I know it's been a while since I made a video, it kind of got off track, so I figured the best way to get back on track is just to get started. The hardest part's just always getting started. So we're going to start with LeetCode problem number 771, joules and stones. That's an 81.8% acceptance rate, so hopefully it should be pretty easy. A disclaimer, I've kind of seen a problem similar to this before, so let's go ahead and get started. So it says that we are given strings J representing the types of stones that are joules and S representing the stones we have. Each character in S is a type of stone that we have, and you want to know how many of the stones are also joules. So basically, I kind of picture it like two piles, stones that I have, and then like a key where J is the key to the stones that are joules. There's some constraints I see here. The letters in J are guaranteed distinct, and all characters in J and S are letters. Letters are case sensitive, so A is different from capital A. They give an example of J equals lowercase a and capital A, and then S has lowercase a, 2 capital A's, and 4 lowercase b's, and the output's 3, and I see that's because we have 3 joules in our S string that are also located in J. So one thing I'm noticing here, just like right off the bat, is we're kind of comparing each character from character or string S to a character in J if it exists. And if it does, it seems like we're incrementing a counter, and that's how we get the total output. Second example is J equals lowercase c, S is two uppercase Z's, and the output 0 because Z and Z are not similar because they're different cases. I guess another constraint here is the length will be at most 50, and the characters in J are distinct, so we won't have lowercase c, in J. Alright, cool. So I think I have a pretty solid understanding of how this problem is. So I said I would follow the umpire, I guess, framework, where U stands for understand, M stands for match, P stands for plan and pseudocode, I stands for implement, R stands for review, and E stands for evaluate. So I kind of want these videos to mimic like how I would feel in a real interview. So let's go through these steps. First, we kind of already understood the problem, or I guess I already understood the problem. Normally in an interview scenario, I would ask some clarifying questions such as, like if it wasn't specified, are lowercase a and capital A the same? Are there any non-alphabetical characters? Different things like that we might want to ask in an interview where these details aren't provided. So my understanding of the problem is that conceptually we have a pile of stones, and we want to know how many of those stones are joules. And so we are given a string of characters that are joules. Each character denotes a joule in that string J. So right off the bat, a brute force solution comes to mind is that for every character in character S, we take a look and see if that character is also in string J, and if it is, we increment a counter. If it's not, we continue on with the next character in string S, and basically that would give us a runtime of O of n times m, where let's say n is the length of string S and m is the length of string j. In terms of space complexity, it would be O of one space because we're not using any additional data structures or that are proportional to the length of the two strings. But assuming we want to optimize for our time complexity and make it better, so with this brute force, let's just write down brute force. We have and we'll add up here like a time complexity. All right, let's see this time. Let's just put a space. Dang, I don't know how to best do this, but let's just put a dot, space, time, and space. With brute force for this problem, we will have a O of n times m runtime, and in terms of space complexity, we'll have O of 1. One way we can optimize it is given a string s equals random, that's our pile of stones that we have, and j being the joules that are given, we have, let's just pick some, like a pretty good test case, like a small one. Let's include a character from s, so let's just say O. Let's include a character that is not in s, so let's say n. Let's also include an uppercase character so we know that our counter doesn't increment when we have a match with a character from string s into character from string j, because they should be different cases. So let's pick capital A, and we can go ahead and test this out. So brute force, we'd go in from every character and check if it's in j, and our expected output should be, it should just be 1, or sorry, I guess I made a mistake. I wanted to include a character that's not in string s, and I put an n, but n does appear in the string s, so let's just put in z. That's the most unlikely character. So here the expected output should be 1 because we have O in both strings. Z is not there and capital A is not there. So you can also do it in the reverse way, where you check for every character in string j, are there characters in string s that match it, and when you come across that, you increment the counter. To improve on this, like a pattern I noticed is we're going to another string every single time when we can kind of cache each character from that string. So when I think of caching, I kind of think of a hash map. So we can basically have a hash map and store one of these strings into the characters from the string into a hash map. So in this case, for example, I'll use string j and I'll store it in a hash map. So my hash map, or here we'd use a hash set because we're not doing key values. We just want to store stuff to look up later. So my hash set would basically be O, Z, and A. Each of these are characters, not objects, but the point's kind of given across. And with the hash set, we would be to do a lookup in a hash set, it's an O of 1 time, or like that's the kind of general consensus that you have an O of 1 lookup time for a hash set. So by doing that, we go through one of the strings and store its characters in a hash set, and when you're iterating through the other string, all you have to do is take a lookup of if that string occurred in the hash set. So for example, and I know I might not be super clear, this is something I want to work on, and one of the reasons why I want to make these videos is to actually get better at articulating my thought process. So here, let's just say we started off in this function, we want to get this output to be 1 and have a match. So we'd initialize our counter. Here I guess I'm starting my pseudocode phase. So we'd have an output, just set it equal to 0, then initialize a hash set, and store one of the string's characters in that hash set. So I picked string j, stored it in this hash set, and now when we iterate through iterate through string s, all we have to do is check if the character that we are iterating, or like the character we're at in string s, if it occurs in the hash map. And there's two scenarios here. So one, if it does, you want to increment output. If exists, increment the output counter. Else you want to do nothing, just continue. And from that we will have the output towards the end, and we can just return the output. And one thing we have to make sure is that we actually, when we're doing this check in the hash map, that we're checking that it's case sensitive. So just a simple O equals capital O will not pass. So it seems like we optimized our solution by implementing or using a hash set. So let's just write out the time and space. So here we will have O of n plus m, because a time complexity, because we're using some amount of time to store the characters from string j into the hash set, and then doing a lookup from, or iterating through the characters in string s and doing that lookup. You can also, I guess, say that this is O of big O of the maximum lengths of the two strings, because when you actually do write out n plus m, the dominating term will take over, and whatever. So here the space complexity we're using is, or the space complexity for this optimized solution is O of m, because we're actually taking m space to store the hash set. So m here is the length of string j, and you can basically visualize how it'd be O of m space. If not, maybe leave a comment and I will expand further and be more detailed in my next videos. This is kind of just like a trial. So cool. So I went through the match and the plan. Let's go ahead and implement it now. So I'm going to take my pseudocode here and go into this thing, into LeetCode, and just leave it there so I can have something to work off of. So let's just say int counter is equal to 0. Let's code this up. So we're going to create a hash set of type character, because we're storing characters. So one of the things is we can't store primitive types in like a Java data type or an object that stores generic types. So yeah, we have to use character instead of char. So here we have a set of characters. We'll call this lookup map is equal to a new hash set of type character that's implied with the new Java 7, I believe, and we're on Java 8 now, but that's been around. Then for every character in string j, let's say char j in string j, let's just go ahead and iterate through it, because then I'd have to do the j.to char array. So for int I is equal to 0, I is less than j.length I plus plus. Let's just go ahead and store it in the lookup map. Lookup map dot add, I believe it is, for, let's call it lookup set. This it's kind of bothering me how I'm kind of varying the wording. So lookup set dot add the character that we're on. So j dot char at I. After we do this, we want to iterate through the string s. And while we're iterating through string s, we want to check if the character occurs in the hash set. If it exists, increment the output character or the output counter. Otherwise, continue. So basically, just if lookup set dot contain s dot char at I, you want to do counter plus plus. And else, we don't have to write an else condition because we'll just continue. And towards the end, you want to return counter. So let's see. We can run through this manually before we go ahead and try to submit it or run the code with the compiler. It's always a good idea because when you're in an interview, you'll be on a whiteboard most likely, and you won't have a compiler to tell you where you messed up. And I mean, more so in the logic rather than semantics and syntax, because I mean, on a whiteboard, I would hope that we don't make many mistakes, but sometimes some mistakes are common. So here we created the counter, initialize it to 0. So if j and s are empty, we'll end up returning 0. We create the lookup set, and we'll add in all the string or the characters from string j into the set. And then after that, we'll iterate through string s. And if the set contains that character that we're on in string s, we'll increment the counter. Towards the end, we return the counter, and that should be good. So some of the edge cases we might want to consider here are if j is null or s is null. These will kind of fail. It will throw an exception. I'm gonna assume for now. I guess in an interview I would state that I'm making the assumption that j and s are not null. Otherwise, we can go ahead and add that check. But let's go ahead and run this code. So we see that my answer was 3, the expected answer was 3, so we got it right. Let's go ahead and test it with all the other solutions, and our answer was accepted. So here, let's go to the review. We can move on to the review stage. So like I said, if we had the case where j or s was null, we should add in those checks so our function doesn't throw in an exception. Some other things I would probably change about this is I'd kind of modularize the code in such a way that this could be its own like helper function, I guess, or this can be its own helper function returning a set. So that way the code is kind of testable, and we over time we won't get this huge function implementation. That's one thing I would definitely do. Also do this in its own helper function. With that way we can take in parameters and we can test it in a fashion that way later on we can maintain this code. For the evaluate portion, we already did the evaluation that this is our time and space complexity. If depending on which one you're optimizing for, you would want to implement either one of these two solutions. If you want to save space, we can kind of take the hit of the brute force n times n. What we can also end up doing is sort both of these strings, j and s, and then iterate through both of them. And we're going to assume that we're using like the, let's say, merge sort or quick sort with an average time complexity of n log n. And by doing that, we'd be able to iterate through both strings in one pass and check and increment the counter. But here, the sorting algorithm actually dominates the time complexity, so the time complexity would be n log n, but our space complexity would be O of 1. So these are some things you might want to mention, like to an interviewer when you're, let's say, if you were given this problem. And by no means necessary is that an exhaustive solution. I'm sure there are other solutions out there. These are just some that come up to my mind, and I'm also I would consider myself to be a beginner and trying to learn. So I feel like I'd be comfortable submitting this code. Cool. So I'm going to try to make the next video, and hopefully this streak keeps going.